Okay, so if you remember the last lesson, 6.2, what we were doing is we were trying to recognize what are the properties of parallelograms. So essentially, in every statement that we were given, it said, if a quadrilateral is a parallelogram, then here's what's true about it. And if you remember, there were a few main things. We said, if a quadrilateral is a parallelogram, then its opposite sides are congruent. If a quadrilateral is a parallelogram, then its opposite angles are congruent, yada, yada, yada. Now what we're going to be doing in this lesson is very similar. We're going to be going back through each of those rules that we proved, but we're also going to be, we're just going in the opposite direction. So let's say that statement A stands for this. Statement A stands for if a quadrilateral is a parallelogram, and I'm going to make that smaller. So if a quadrilateral is a parallelogram, and then statement B is then one of our rules from last class, like then the opposite angles are congruent, then the opposite sides are congruent, yada, yada, yada. So let's say that statement A is if a quadrilateral is a parallelogram, and statement B is then, and then fill in the blank. Its opposite sides are congruent. Its opposite angles are congruent. The diagonals bisect each other. The consecutive angles are supplementary, so on and so forth. Those are our 4 big rules that we learned. Well, so all of our statements last class were if A, then B. This is a way to write informal argument. This is a way to write arguments. And what this argument says, if this is true, this arrow communicates then, this is also true. Right? So last class what we were doing is we were doing if A then B, where A was if the quadrilateral is a parallelogram then. What we're going to be doing this class is we're doing all the same rules, but this time we're going B then A. So we're looking at parallelograms and we're saying, oh, well, if a parallelogram, for example, has if a quadrilateral's opposite sides are congruent, then it is a parallelogram. Okay, so we're using these qualities that we know to be true about parallelograms to prove that whether or not something is a parallelogram. Okay, so there's not really much to this lesson. We're just learning all the same rules that we did last time, but we're also learning that they are true in both directions. So as you can see here, theorem 6.6 says this. If both pairs of opposite sides of a quadrilateral are congruent, then we know it's a parallelogram. So if I have a quadrilateral, and it doesn't explicitly say that it's a quadrilateral, but I'm able to recognize that the opposite sides are congruent like we can here because of the tick marks, then we can say for certain that this is how you write quadrilaterals. Quadrilateral A, B, C, D is a parallelogram. Because we can see clearly that the opposite sides are congruent. In the same way, if both pairs of opposite angles of a quadrilateral are congruent, then it is also a parallelogram. Okay, so we learned last time that parallelograms, the opposite angles are congruent. So if we have a quadrilateral and it doesn't explicitly say that it is a parallelogram, but we look at it and we see very clearly that the opposite angles are congruent, then we can say for certain that this is a parallelogram. Okay, so I hope you're starting to see where we're going. This is quite easy. Okay, now let's look at this. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then it is a parallelogram. This is the inverse of the rule that said if a quadrilateral's consecutive angles are supplementary, then it is a parallelogram, that parallelograms, their consecutive angles are supplementary. So if we look at a quadrilateral and angle A is supplementary to both angle B and angle D, which that's exactly what this is saying. So it's saying if we have an angle in a quadrilateral and that angle is supplementary to both of its consecutive angles, then we can say for certain that it is a parallelogram. Okay, so that's the exact same rule that we just learned, but we're just learning it in reverse. Let's keep going. This is not hard. If the diagonals of a quadrilateral bisect each other, then we can say for certain that it is a parallelogram. So again, if we have a quadrilateral and we know the diagonals and we're given this picture, and it says that because of the tick marks, we can see that the diagonals bisect each other, then we can say for certain that this is a parallelogram. So we can use these rules that we learned in the last lesson to be able to decide whether or not quadrilaterals are parallelograms. That's all that this lesson is about, is we can use these rules that we just learned to prove whether or not a quadrilateral is a parallelogram. Okay, let's go through one more, and this is a new one. Okay, if one pair of opposite sides of a quadrilateral are both congruent and parallel, then it is a parallelogram. Okay, so this is new. So now, remember we just learned theorem 6.6 said that if both pairs of opposite sides are congruent, we can say for certain is a parallelogram. But that's not all we can know. If we know, like we do in this picture right here, that there's one pair of opposite sides that are congruent and parallel, then we can say, yep, ABCD is a parallelogram. Okay, so we can use all those rules to prove whether or not something is a parallelogram. So what I want you to do now is we're going to go through 6 examples, and I want you to just look at them and determine whether or not we know enough about these quadrilaterals to say that they are a parallelogram or not. Okay, so we're going to go through these first 2, and then after that I want you to do the rest of them by yourself, and then come show me your work when you are done, so I can check and make sure that these are all right. Look very closely. It doesn't just say, are these parallelograms? It also says why. So you need to list the theorem. Okay. So let's look at this first one. Is this a parallelogram? Well, obviously here the answer is yes. And the why is theorem 6.10, which is the one that we just learned that says that if one pair of opposite sides is both congruent and parallel, then it is a parallelogram. So that one is pretty easy. So we know that one is yes for sure. That's a parallelogram. But let's look at this one. We know that we have 2 sides that are parallel, and then we have 2 sides that are congruent. But we don't know that both pairs of opposite sides are congruent. We don't know anything about the angles. And the 2 sides that we know are congruent and parallel are not the same. So we do not know enough to be able to say whether or not this is a parallelogram. In fact, if this is all we knew about this quadrilateral, we would say for certain that it is not a parallelogram. Okay, so there you go. There's the idea. I want you to continue through and do all of these, and then when you're done, make sure you list the theorem why, and then when you're done, come and check those with me. Thank you.